of one designated for a younger age group and the other for an older age group. In the younger age group's box, there will be parts of several color-coded 3D models of a dinosaur that they can dig out and clean. Then using a mold, they can place these pieces in the correct order to see their finished dinosaur. In the older age group's box, there will be teeth from a mosasaur, a carnivorous marine reptile, that they can also dig out and clean. Comparing these teeth to pictures of omnivore and herbivore teeth, they can see the different functions of different teeth corresponding to their shape.
Our activity aims to teach both kids and adults about how to carefully excavate, cast, and compare the anatomy of dinosaurs with fossilized models through an interactive and engaging experience. DinoFest encourages the participation of people of all ages to learn about these fascinating creatures through a new perspective, and we're glad we get the opportunity to perform that here.
So we would be targeting both younger and older age groups. Now for the younger demographic, we would talk about the fossil digging and cleaning process. And so after the children find their fossils from the sandbox, the volunteer would then focus on explaining the dinosaur's bone structure and how fossils develop. The older demographic will also learn about the fossil digging and cleaning process, except that once they find their fossils from the sandbox, the volunteer would then focus on explaining and helping the participant comprehend comparative anatomy. And using the fossils exhumed from the dig, the participant will quickly examine the bone structure and try to hypothesize generally like what dinosaur that bone may have belonged to. And so another goal we are striving to achieve with this activity is to correct the common misconception that fossils are nothing more than raw bones. So we want to teach the participants that fossils are actually formed through permineralization, or the slow seeping of silt into the bone as tissue decomposes, strengthening it and hardening it to one day be found as fossil.
So most of our talking points are going to be questions that the volunteers can ask the guests. Some of the questions include, what are cast fossils? Cast fossils and the process that created them. Cast fossils are an imprint of...
Questions from our judges?
I have a question for Team 1. You got me all excited. You talked about CRISPR-Cas9, but never quite actually explained how it works. Would anybody like to give me a quick summary? Oh, throw that microphone away.
Okay, so from what we researched, CRISPR-Cas9 is basically a gene editing system that has recently come into play. So it's mainly been used by like parents who want to design their own babies, which is, that's like unspeakable in my opinion. Well, I mean they do it, so can't really stop that. And so basically, it kind of like weakens like the cell's immune system. That way, you can like introduce like new, I guess, like features into the cell itself. Yeah. That way, you can like actually edit the gene.
Okay, so CRISPR-Cas9 is a gene editing system that is based off of bacterial immunity. So that was the origin of the gene editing system, and what happens is that after a gene is taken out, it will be replaced with another gene with a more favorable trait. So that's what is being used in the concept of designer babies.
Great explanation. Wow. Yes. Anybody else have a question? Okay. Similar train of thought. I was really intrigued by the discussion regarding the woolly mammoth. Can someone explain the statement that over time the elephants will adapt to the characteristics of the woolly mammoth? What would be the mechanism behind that? How would that work?
Yes, so in the specific type of the elephant, an Asian elephant, has about 99% of the same DNA of a woolly mammoth. And so what they're trying to do using CRISPR-Cas9 is, well, make a woolly mammoth. It's not going to be an exact clone, because that would be a lot harder, but it's going to have pretty much every characteristic of a woolly mammoth without being a woolly mammoth. And so what, as I said, it's going to help the climate in the Russian tundra. And that's like, without like Jurassic Park, it was just for like festival, like entertainment and stuff. But it's actually going to help our that ecosystem. And so that's the main reason why they're trying to do it.
Thank you.
If that answers your question.
Yes, it does. Thank you.
Hi. On T2, would someone like to explain a little bit further about how bone goes to fossil?
Okay, so the way that bones become fossil is once the organism dies, and then the bones are placed into into silts. Pressure builds over them, and then inside, it either becomes a cast fossil or a mold fossil. So over time, minerals from the silt goes into the bones and like solidifies it, and then if not, then over time it will gradually disintegrate and then just like disappear, leaving behind a sort of mold for the fossil. Yeah.
Thanks.
Any other questions?
On the first group, I see that being more complex to understand for an older kid. How young do you think the youngest would be, and how would you adapt it for that age?
I think that youngest would be around 14, 15, because that's the age of like transitioning into high school, and then usually the first science subject going into high school is biology. I think that it would be an easier thing to start off with first, like what are genes and how they actually fit into a DNA model, and then doing that, the volunteer would hold up the DNA model and then give it to the high school kids to play around with and figure out what they can do with and with which bases they can link up to one another. And then after the basic explanation, we can then explain like the nucleotides and how they like their base pairs and which are purines and pyrimidines. And then from there, we can go on to genetic modification and why people would want to modify genes in the first place.
So this wouldn't work for a younger kid?
No, that's why we have the Plato station.
Thank you.
Thank you all.